So one of the things we want to do, in fact, the first thing we want to do when we start to try to graph these, is we want to be able to find the zeros of the polynomial function, or when they're crossing the x-axis. Remember, zeros are the same thing as x-intercepts, so they're going to use that a lot. And they also sometimes call them roots of the polynomial. But you might not see that quite as much, especially in this section. Okay, they're probably going to talk about x-intercepts because we're graphing them, all right? So it says find the x-intercepts of, here's the function. Well, the way to do that is we're setting the function equal to 0. They're the zeros, and so we're saying when does this function equal 0? Okay, so in this case we can factor out x squared, so let's do that. That gives us x to the 4th minus 3x squared plus 2. And so we have x squared. This trinomial in here will actually factor into x squared minus 2 and x squared minus 1. Now, we can debate how you want to write this, but the x squared, I'll skip over the x squared minus 2 for a minute, because this factors, it's the difference of squares, so x plus 1 and x minus 1. So we can see 3 of the zeros that we have. The one that might be tricky is this one right here. And so what you can do is you can go over to the side and say, well, when does x squared minus 2 equal 0? X squared equals 2. Take the square root of both sides, and so x equals plus or minus the square root of 2. Okay, so we've done that type of work before. And so we're going to have these zeros, or x-intercepts, sorry, x-intercepts. And my guess is they're going to write them as ordered pairs, but I'm not sure. You're going to get a 0 from here, so 0, 0. Because if x is 0, that whole function was equal to 0. You're going to have one with negative square root 2, comma 0. You're going to have one with positive square root 2, comma 0. You're also going to have one from here, negative 1, comma 0, and one from here, 1, comma 0. So remember, we're finding those intercepts based on the zero product principle where we set each factor equal to 0. That could be 0, that could be 0, which that work we did over here. That could be 0. You might see it by just looking at it, or you could write x plus 1 equals 0 and solve that linear equation. Same thing there. Okay, so we found the x-intercepts. Now we have some more examples of finding x-intercepts, and they're going to be involving some other techniques.